Okay, hello, Team 6C. We're going to look at our next math lesson today here with Jimmy. Some of you might have noticed that I'm at lesson 8 today instead of lesson 7. We're going to skip lesson 7. We're going to move all the way up to lesson 8, which is called variability in a data distribution. Okay, so we're going to look at two cities today. We're going to look at New York City and San Francisco. And Robert's family is trying to decide where they should move. Obviously, we're talking about two different extremes in the United States. Robert's family is planning to move to either New York City or San Francisco. Robert has a cousin in San Francisco and asked her how she likes living in a climate as warm as San Francisco. She replied that it doesn't get very warm in San Francisco. He was surprised, and since temperature was one of the criteria he was going to use to form his opinion about where to move, he decided to investigate the temperature distributions for New York City and San Francisco. The table below gives average temperatures in degree Fahrenheit for each month of the two cities. So what I'd like for you to do, we kind of did a little bit of mean median mode on our daily math review when we were back at school. I'm going to ask you to find the mean of these two cities. What that means is you're going to have to pause your lesson, get yourself a calculator or your cell phone or something where you can add up the scores. We're going to add up, for example, 39 plus 42 plus 50, so we're going to add all of them up. Now, when you add all of them up, I am going to tell you you're going to get a large score in the 700s, and when you do the same thing for San Francisco, you're going to get also a score in the 700s. So if you would pause your video for me and add up all the temperatures for New York City and San Francisco. Okay, so those of you that actually added those up, you should have noticed that New York City has a total of 756 and San Francisco 768. Now we can recall back from our days when we were at school that mean means is kind of the average. We add up all of the values and we have to divide by the number of numbers we have. So if you notice, we're looking at the 12 months, so we're obviously going to divide by 12 for both of these. So we'll divide by 12, and we're going to find out the two temperatures. The New York City, the average or mean is 63, and the average or mean for San Francisco is 64. So when you go down here, down to problem number 1, it says to calculate. Well, we just did that. We calculated the mean. So I wrote the names of both cities, and I wrote underneath each name the mean for both. Very close, aren't they? 63 and 64. But for those of you that have visited both of those locations, you will know that the temperature is not very similar. Some of you are noticing already here in New York City, we have a low here, looks like a 39 in the month of January. And then the temperature looks like it gets up to about 85. San Francisco, we have a low. It doesn't get quite as cold. So we're going to kind of look at that information. Problem number 2 says, recall that Robert is trying to decide to which city he wants to move. What is your advice to him based on comparing the mean? So if you look at the mean, we don't really have a lot of information for him to pick one over the other. So I put on my answer. I said since the means are almost the same, it looks like Robert could move to either city. So if you need to pause my video so that you can write your answer down, please do that now. Okay, so if you have that written down, we're going to now move on to the fact that obviously we don't have enough information here yet for Robert to know exactly where to move. So we're going to start looking at the data a little bit more closely. We're going to look at something called variability. Variability basically means the different values we have. As we were looking at the chart up here, we noticed that we're looking in New York City from 39 to a high of 85. And here in San Francisco, it looks like maybe a low of 57. And it looks like to me a high of 70. And so that's what we're going to look at a little bit more closely, the variability, and if that's going to affect us. So if you would go ahead and turn to the next page. Okay, so what somebody has already done for us is they went ahead, and you'll have to look in your math book because this is kind of small, but you'll notice we have dots here. We have a dot plot for all the temperatures, the 12 temperatures in New York and the 12 temperatures in San Francisco. If you notice, I went ahead and wrote a little 63 here and a little 64 here just to help me remember the mean that we found out for the two cities on the previous page. If we go down to this, it asks us to mark the location of the mean using this triangle right here. So we said 63 for New York. 63 to me is about right there, so I'll put my triangle right there. 64, I'm going to guess I'm going to put it about right there. So that triangle is going to represent our mean, so we did that. Then it says, well, how do the two distributions compare based on their means? Well, if you noticed, the means are pretty similar. I mean, they're not too far off, so I wrote the means are about the same. We move down to the fourth question, number 4, and it says, describe now the variability of the New York City temperatures from the mean. Well, let's look up here. We see the means here. Let's look at all the dots on the dot plot. Look how they are spread out. That is a lot of variability, okay? So I wrote that the temperatures are widespread around the mean. And I even went ahead and said from 40 degrees to 85. And it actually was down to 39. Now, when I look at the variability, obviously, of San Francisco, the dots are not quite as spread out. They're pretty close here to this mean. And sometimes we use the word compact, meaning they're all close together. So on number 5, when it asked me to describe the variability of the data for San Francisco, I said that the temperatures are compact around the mean from 57 to 70 degrees. So if you would like to pause your screen so that you can write this down, you can do that. I'm going to actually go ahead and cross this out and put 39 because to me the lowest temperature was 39. So once you are done writing this down, you can go ahead and flip over to the next page, but please make sure you pause your screen if you are still working. All right, so on the next page, it basically is going to ask you the questions that we just answered. It says, compare the amount of variability in the two distributions. Is the variability about the same or different? Well, obviously, we looked at the dots, and the dots were either very spread out or compact, so I said that the variability is very different. The second part of the question said, if different, which monthly temperature distribution has more variability? Okay, which one had more? Well, obviously, the variability in New York City was greater. Remember, we went from 39 all the way up to 85. So you may pause your screen so that you can write this information down. All right, so question number 7 says, if Robert prefers to choose the city where the temperatures vary the least, sorry, Jimmy, vary the least from month to month. Least meaning there's not a lot of variability. The temperatures are very similar. Well, we looked at that earlier and we found out that San Francisco, so what I did is I put here, he should choose San Francisco because the temperatures range from 57 to 70. To me, that's not a lot of variability. Okay, so now we're going to move on to example 3. Example 3, we're going to look at something now that is, the mean is going to use to be describe the typical value for the entire distribution. So we're going to look at the mean scores and we're going to see if the mean represents all the information. So for example, if I flip my book over here, you notice the 2 here with our temperatures. The mean did a great job of describing the temperatures here in San Francisco. Most of them were close to that. However, the mean does not really describe the temperatures in New York City because if you notice, there's a lot of variety. Most of the temperatures were not close to the mean. Okay, so that's kind of what we're going to look at now. The question now is about some 6th grade students and how their time limit it takes them to get to school. It says, consider the following 2 distributions of times it takes 6 students to get to school in the morning and to go home from school in the afternoon. So here's my 6 students in the morning, their times, and in the afternoon. So the first thing I'm going to ask you to do is I'm going to ask you to find the mean for both of them. Now remember, the mean is to add all the numbers up and then divide by the number of numbers. Well, we have here 6, so we're going to have to divide by 6. So go ahead and use your calculator, pause your screen, and see if you can figure out how to solve the mean. So hopefully you paused your screen and found out that they both equaled 84. Obviously, I'm going to take 84 and divide it by 6, and I found out that the mean or average time it takes the students to get to school in the morning and in the afternoon happened to be 14. Okay, so we need to remember that the mean score is 14. Go ahead and flip your books over to the next page. All right, so I kind of put the numbers right here for us. So we don't have to flip back and forth, but what we're going to do is we're going to look at the numbers for the morning and we're going to make a dot plot. So we have here 11, we have 12, We have 2 under the 14. We have the 16 and the 17. And then for the afternoon dots, we're going to put 1 was at 6, 1 was at the 10, and the 13. 18 gets 2, and the 19 gets 1. Okay, so we've made our dot plot. Do you remember what the mean was? Okay, well, the mean for the morning, remember, was 14. And the mean for the afternoon, remember, was 14. Let's go ahead and put our triangle representing the mean up here on our dot plot. So here's 14 for the morning and 14. So let's look and see. Here's the mean. Looks like to me that for the morning, the data is all pretty close to the mean. The afternoon, not so much. Look where the mean is. We've got a lot of variety here. We've, got numbers down from 6 all the way here to 19. So this one to me is the mean. It is a good indicator. Okay. So for which distribution does the mean give a more precise indicator? Well, we just looked at that and we said the morning mean is more precise. And then I said because the afternoon data is spread out. So if we look up here, the afternoon data, my information was kind of spread out far away from the mean. So you can go ahead and write that answer down. If you need to pause your screen, please do so. When you are finished writing your answer down, we're going to flip over to the last page and talk about jelly beans. All right, let's look here. Now, I'm going to kind of shorten this a little bit because I'm going to ask you to work on some extra math later for your homework, those of you that haven't finished that. So we're going to go ahead and cross out sweet and yum. Okay? My story says this. Consider the following data on the number of green jelly beans in 7 bags of jelly beans. Come over here, Jimmy. From each of 5 different candy manufacturers. Well, we're not going to do 5. We're going to look at 3. Okay, so here's my all good manufacturer. In one bag, there were 40 green jelly beans. In the second bag, 40. In the third bag, and so forth. You will notice, and I have covered up here, I want you to make a dot plot for all good, best, and delight. I want you to put dots on each one of these. Then I want you to put this triangle symbol representing the mean. Now, if you looked at the directions where I circled, the mean has already been solved for us. The mean for all of the manufacturers is 42. So you're going to put your triangle at 42 for all of these. Go ahead and pause your screen so that you have some time to work on this. And then when you're ready, press play. And as soon as when you press play, I'm going to have the answers for all 3 dot plots up on the screen. Okay, so go ahead and pause your screen, please. Okay, so here are my dot plots for the 3 manufacturers. I have here all good with my dots and the mean at 42. Best manufacturer with the dots and the mean. And last but not least, the delight manufacturer and the dots and the mean. Over here on the side, I kind of wrote a note that I would like for us to do. And I would like for us to order from the variability from least to most. Remember, the variability means the different variety if we have a spread out data. So if you notice, you have here the mean for all good. Most of the dots are pretty close to the mean. For the best, they're spread out a little bit. Delight, they're spread out a little bit. So to me, the one that shows the least variability would be all good. Okay, there's not a lot of different variety away from the mean. They're all pretty close. Now, if I had to look at the other 2, best, and here's the dots sprawled out here, and then delight. If I notice, to me, I think where the mean is, I think with delight, most of the dots are closer to the mean than up here with best. Best has some little outliers here. So I'm going to number this one 2, which then means obviously this will be 3. Okay, and then the last thing I would like for us to do before we close out for today is I'd like for us to look at these 3 manufacturers, and we're going to put a star next to the one where the mean is a better indicator. Better indicator, meaning if I look at the mean, they're all 42, which manufacturer has most of the data or information close to the mean? So does the mean for here, for all good, does the mean represent most of this information? does the mean here represent most of this information? Or for the delight, does the mean here represent most of the information? So to me, when I made that circle like that and I look, to me, the better indicator out of all three is going to be all good, because most of those values are close to the mean. Okay, so once you finish writing this down, those of you that have not done your extra math, which I've noticed on the program, that's going to be your homework today, is to go ahead and do an extra math lesson. The rest of you, you do not have a math assignment, and I will see you all tomorrow.